Hello everyone, what is up? Welcome to today's daily math question, and in today's video, we are going to be solving the equation 5 to the power of x plus 3 equals 7 to the power of x plus 3, and we need to find and solve for the value of x. Now, believe it or not, there is actually two different ways to solve this problem. There's a pre-cal way and a calculus 1 way, and I'm going to show you guys both ways how to do this. So anyways, first, let's start with the pre-cal method. So first I'm going to rewrite the equation, 5 to the power of 3x equals 7 to the power of x plus 3. So anyways, in pre-cal, you were taught that the only way to solve this equation is to get the bases equal to each other so that you can set the exponents equal to each other. So in order to do this, we just need to know all of our exponent rules so that we can manipulate the equation into getting the bases the same. So first of all, whenever you see addition in the exponent, you know that we could actually expand this to turn into 5x times 5 to the power of 3. And again, same thing on this side. Whenever you see addition in the exponent or the power, that means that this can be broken up into 7x times 7 to the power of 3. And then from here, we want to get every term with the same power or the same exponent on each side. So from here on the right side, we're going to divide by 7x on both sides. And then we are also going to divide by 5 to the power of 3 on each side, so that we end up getting 5 to the power of x over 7 to the power of x equals 7 to the power of 3 over 5 to the power of 3. Now keep in mind, when dividing, if both the numerator and the denominator have the exact same value, then the whole thing is to that power. So anyways, we can actually rewrite this as 5/7 to the power of x equals 7/5 to the power of 3. And now from here, in order to get the bases the same, we are actually going to take the reciprocal of 7/5 by taking the by raising this to the power of -1, because in case you don't know, whenever you raise something to a negative power, or like the -1 for example, it basically flips the numerator and denominator. So we're going to go ahead and rewrite the 5/7 x equals, and again, we're going to take the reciprocal of 7/5, and we are going to set this to the power of -3. And now finally, now that we have the bases equal to each other, we set the exponents equal to each other, and x is going to be equal to -3. Now it's time for the calculus route. So in calculus, we can use something called logarithmic differentiation in order to solve this equation. And in order to do that, what we need to do is first we need to take the natural log, or ln, of both sides. So we're going to have ln of 5 to the power of x plus 3 equals the ln, or natural log, of 7 to the power of x plus 3. And using our logarithm rules, we know that like this power, the x plus 3, can actually shift in front. So we're going to have x plus 3 times ln 5 equals, and again, we can shift the x plus 3 in front. So we're going to have x plus 3 times ln 7. And then from here, we want to get the terms on the same side. So we are actually going to subtract by x plus 3 natural log of 7 on both sides. And anyways, by doing that, I'm going to go ahead and rewrite our equation. We are going to get x plus 3 times ln 5 minus x plus 3 times ln 7. And from here, we can take the greatest common factor out, which is x plus 3. And that is going to leave us with x plus 3 times ln 5 minus ln 7. And again, knowing our logarithm rules, oh, and this equals 0, by the way. Knowing our logarithm rules, we can actually condense these two logs right here, because whenever you have two logarithms, subtracting each other, it actually is the same thing as division. So we are going to change this to x plus 3 times ln of 5 divided by 7 equals 0. And then from here, we are just going to simply set each of these parts equal to 0. So x plus 3 equals 0. Subtract 3 on both sides. We're going to have x is equal to negative 3. And then over here, we're going to take ln of 5/7 equals 0. And when you plug the value of the natural logarithm of 5/7, you are going to get about roughly negative 0.33, which does not equal 0, which means that x equals negative 3 is your only valid answer. But anyways, that is how you solve the equation 5 to the power of x plus 3 equals 7 to the power of x plus 3 for the value of x.